Hello, everyone, and welcome to our poster presentation on investigation of chlorophyll concentration variation in the equatorial Pacific during El Nino events. Today, the poster will be presented by Kelly Krause, myself, Jody Lee Rigdon, Brandon Rose, and Cecilia Thompson. I will start us off with the introduction and background. The goals of this study were to compare chlorophyll concentrations for normal times versus El Nino event times. We use sea surface temperatures as a proxy for El Nino events in the equatorial Pacific, and we used chlorophyll as a basis for predicting phytoplankton biomass. Downwelling, shift in currents or winds, increased sea surface temperature, and surface nutrients all contribute to chlorophyll concentrations. El Nino events have increased in both frequency and intensity due to global warming. With both of these things happening, we hypothesized that average monthly sea surface temperatures would increase and chlorophyll concentrations would decrease during an El Nino event compared to normal years.
So we obtained our data from the Tau Triton array, and we had 10 sampling locations across the equatorial Pacific for both temperature and chlorophyll concentrations, as you can see in figure 1. A correlation analysis was also conducted to identify the relationship, or if there was one, between temperature and chlorophyll concentrations. And then the temperature and chlorophyll data were also analyzed versus time at each site to highlight the variation throughout the sampling period of both temperature and chlorophyll. Mean monthly chlorophyll values and their associated standard error were then calculated for El Nino and non-El Nino events. And then to test if there was any significant difference, a t-test was utilized with the standard error.
So to get into the results, in general, we found a relationship between chlorophyll concentration and water temperature. While this relationship was not statistically significant, chlorophyll and temperature have a notable inverse linear relationship. We found a temperature range of 20.1 to 30.9 degrees Celsius and a chlorophyll range of 0.036 to 0.52 milligrams per meter cubed. We found that there were annual seasonal variations in both El Nino and normal years, with chlorophyll concentration maximums in summer months and minimums in winter months, which we can see here in figure 3 on the left. And then finally, when comparing El Nino years to normal years across all buoys, the average chlorophyll concentrations were seemingly higher during the normal years than El Nino years, which we can see highlighted in figure 4 on the left.
And finally, to bring us on home, I will go over the discussion and conclusions. So first off, we found that chlorophyll concentrations decrease in response to elevated sea surface temperatures. So this is not anything too novel, as it has been evidenced in some prior research. That is actually part of the reason that we are monitoring El Nino events, because of that kind of base level productivity change. But then moving into some of our more novel conclusions, we found that during El Nino years, upwelling in the Southeast Pacific is drastically reduced. This reduced upwelling results in higher mean surface water temperatures and subsequently lower chlorophyll concentrations due to the lack of that cold, nutrient-rich water that is coming up from the deep ocean, as that deep water hits the west coast of South America there and pushes up to the surface. This has a big impact on that local environment there, just kind of in the basic ecology, but then also on a more broad scale, it has lots of global climatological effects, as well as even global ecological effects because of that reduced primary productivity and general chlorophyll concentrations. And finally, as global sea surface temperature continues to rise and El Nino events increase in both frequency and intensity due to global warming, phytoplankton biomass in the equatorial Pacific is susceptible to depletion. And at this point, it is mainly small scale during these events, but if this trend persists, it could end up being a long-term effect where this general phytoplankton biomass is uniformly lowered across the time of the entire year.